Friends, so today we are going to discuss distributed locking. So this is our last topic for our building blocks. So if you are new, so this is a high level design series. So today we are at here and we have all the other topic already discussed. And if you wanna see the notes, so I usually upload the notes here, just like a system design, and then we have HLD, and then we have these basics and then building blocks here. So today's topic as well, I already uploaded here, distributed locking, right? So I will put the link in the description as well. So let's get started. Distributed locking, very, very important concept for our high level design. So most of the time, this question will gonna ask. Okay, so without wasting and time, let's start it. Let's get started. So locking, right? First of all, let's understand what is locking. Imagine. So first of all, why we need distributed locking? Okay. So you are application running on single server, right? Client server. If two thread came on the same object, we can use synchronized re and turn log semaphore that are enough because all the threads are running in one server, like one GVM, right? But we discussed like before that we were using the same before distribution, right? Distributed system, we were using the same thing. Right now in today's world we have distributed systems, right? So we gonna use distributed locking as well. Big companies and their application, big big companies application, so little bit sentence mistake. So because I write myself, big companies application doesn't run on a single server. It may run on like this: load balancer and server 1, 2, 3, and each server has its own JVM, own memory, own logs. Okay, now imagine user A is in server 1, user B is server 2. Okay, and both try to access account 1 to 3 at the time t or time same time. Okay, now server 1 execute synchronized account, server 2 also execute synchronized account. Now what will gonna happen? These logs are completely different, right? Each server thinks I own the log, right? Now both will update the database. So this is the issue. Okay, this is the issue. When both server update the same thing, same number, same account, that will be the issue. Let's understand with the example. Now, suppose we have one phone left in Flipkart, right? Two customer purchase is simultaneously. Customer A, server 1, customer B, server 2. Without distributed locking, no, without distributed locking, both servers read stock 1. One will make 0, other will make -2. Company will sold 2 phone, but it had only 1. So this is a issue. Okay. Now what's the solution? We need one lock that every server can understand. Okay. One lock that every server can understand. Just like as locking server, server 1, server 2, like all the mechanism will be like all this mechanism will be understandable by all the servers. So only one server get lock success, other will wait. Okay. Now before modifying data, sorry, ask. Okay, so some sort of we need to implement like this: client request, load balancer, service ABC, then we're gonna have distributed lock, right? Before modifying the data, each service ask, can I get a lock? Yes, continue, otherwise wait. Simple. Okay. Now when we will achieve this thing, then it will be very easy. Workflow will be like as, sir, suppose order 101 need processing. Okay. Now step 1, server A request log 101. Redis replied granted. Okay, so now server A has lock. Okay. Now step two. This is a step one. Listen carefully. Step two. Server B also requested lock 101. Redis replied already lock. B waits. Okay. When order 101 is logged by server A, if server B, my writing is a little bit bad. So if server B, okay, wanna get the log for the same order, right? So in between Redis says, Bhaiya wait, it is already allocated by server A. Okay, so this will prevent all the issues. Now server A updates the balance, like update database, just like as inventory, payment status, right? Then server release log. Now order is another one is unlocked. Now Redis now gives log to server B. Perfect synchronization. Okay, so this is our perfect locking mechanism. Now evolution of locks. How locks comes, or we can say types of lock, something like that. No lock. Then first of all, like how locks comes. First of all, we don't have any lock. Then we have single lock, read lock, optimistic, pessimistic, database lock, distributed lock. So out of them, optimistic and pessimistic lock are very, very important. Very, very important. If anyone will ask, an interview will ask about locks, he will definitely will ask optimistic and pessimistic. But let's discuss one by one quickly. No lock. Simple. Two threads updating the same account. Thread A. So balance is 100. Thread A withdraw 20. Thread B withdraw 30. So both read value A calculation will be like this: 120, 130. Okay, so at last, whichever the thread will be at last, that will show the final answer. Might be 70, might be 80 accordingly, right? But expectation was 50. So without log, this will be a issue, right? Now, mutex log, like mutual exclusive. Only one thread enter the critical section. Just like as we discussed above. Thread A, get log, critical section, release log, then thread B will get the log. And wait. Otherwise it will wait. Okay. So whatever we were doing in our traditional programming. Okay. Now, third log is read write log. What does it means? Maximum time. Suppose we have 100 users, right? So we're gonna say read write. So only one will be serving write operations, right? Rest will be serving read operations. Meaning sometimes 100 users are only read only, right? Only one write, one user writes. Should reader wait? No. Instead, thread A, B, C can run together. Now, what does it means? Meaning, uh, we're gonna have a read write system, right? So maximum will be read, minimum will be write. Okay. So we're gonna say thread A, B, C, D. Okay. So out of three thread ABC work with read users. Thread D work with write user. Okay. In that way, this will get managed. Okay. Oh, so same example here as well. Writer D, thread D must wait. Okay. Meaning the thing will be same, right? The thing will be same. Meaning they will wait with they will wait for each other because it will a kind of a lock, right? Otherwise, result will be issue. Just like as if we have 100 value, right? A, B, C are read, okay, and if they are reading, they will put a lock. And suppose D has updated the 100 to 90, okay. So if there will be no locking system, then they will read dirty value, okay. So first of all, lock, when lock get released, then it will get a lock, perform the operation -10, then lock will be released. Okay, then again it will read 90 value lock, right? This is our read write lock. Now, this is an example. You can go through simple per of thousands of users reading products and one admin updating a many readers, single writer. So now, very important thing is coming, optimistic lock. Now, what is optimistic lock? Assumption. Nobody will modify the data. Instead of locking, check later. Okay, so this is the optimistic lock deals with versioning, right? Versioning, meaning we have thread A, we have thread B. Okay, so suppose we have some transaction T. Okay, so with the version, so every time we have a version, transaction T with version 1. So thread A get the log, sorry, the thread A read this transaction 1, it has version 1. Thread B read the version, it has version 1. Okay, so it read T1, it read T1. Okay. Now suppose thread A updated transaction 1 to transaction 2. It will get updated to transaction 2. It updated transaction 2. Okay. Now whenever B will going to update transaction 2, okay, but that time database like this destination check, it has transaction 1, so it will not gonna update, it will getting fail. Okay, it will get fail. Then again, if B read again, suppose now write is failed, right? Now again, if we take the same example, if B reads, it read T2, right? And if A reads, it reads T2. Okay, again. Now suppose P get a chance and it updated transaction from T2 to T3. Okay, and same thing. If thread A will gonna update from T2 to T4 or something else, okay, but it will check there is no T2, it will break. Okay, so version maintaining. So this was happening in, not was, this is happening in optimistic locking. Okay, so version 10, thread A reads, version 10, thread B reads. Now version 10, thread A updates. Version becomes 11. Thread B now tries to, database says expected version 10, but actual version 11. Update rejected. Whatever I explained. Okay. This is our optimistic locking. Now, pessimistic locking. So it works with our old thing, right? Meaning opposite assumption. Assume conflict will happen, lock first, then update. Thread A get lock, update updates, unlock. Thread B will wait. The same thing, whatever we discussed until now. Thread A will get a lock on transaction. Okay. Thread B, if we trying to get a lock, it will wait. Thread B will wait. Now it will update from T1 to T2. Okay. Then it will release lock. Then after that, it will get lock. Right. So this is the pessimistic lock. Okay. Pessimistic locking. So this is only a main important. Optimistic deals with versioning. Pessimistic deals with wait update thing. Right. Now database lock, already, right? So we have a row log, stable log, page log, schema log. So when we write update, it go with row by row locking. If we use alter, it locks the whole table, right? Now, just a comparison. You can read it out later. And this is the main like points. Mutex protect shared memory within a single JVM. Okay, yeah, let's go see this as well. Mutex, single JVM, read write, single JVM. Again, write starvation problem. These are problems. Heavy read system, again, single process, single JVM. Okay. Optimistic, database, pessimistic, database, database log, database, distributed log, mutual, multiple servers. Now, here, read a log, when reads are much more frequent than writes, we're gonna go with read write. Optimistic, use when these are kind of trade-offs. Okay. Use when conflict are rare and you want maximum throughput. Okay, maximum throughput. Here, when conflict are common, data consistency is critical. Data consistency is critical. We're gonna go with pessimistic log. Now, database log. Let the database enforce consistency for rows, tables, whatever. We don't like much care about these database logs. It depends on our query, right? Distributed logs use when multiple application instances across different servers must coordinate access to the shared sources, cron jobs, this and that. Okay, so out of them, main are optimistic, pessimistic. Need maximum throughput, need data consistency is critical. Okay, so these are the distributed locking and types of locking. I hope you clear out everything. If you have still doubt, you can comment or you can search. I will post my Topet link as well. You can schedule a one-on-one with me as well if you want. Okay. So for now, I'm closing this video. And if you're new, so you can subscribe this channel because uh, now I will be having uh, this trade-offs. Very, very important. Upcoming topics are these vertical scaling, concurrency parallelism, long polling, like these are very, very important. RPC, REST. Okay. So if you're new, then subscribe to the channel and be with me. And let's learn together and let's crack all the interviews. Okay. And again, low level design, we're gonna write a whole code. Right. We're gonna write whole code for this low level design. Even after that, whatever we are doing here, we're gonna write code for this as well, but not now. We're gonna cover all the topics. Then we're gonna have all these low level design. We're gonna code this and then we'll come back or might we will jump to DSA as well. We have a lot of things to cover. Okay. So for now, we can say bye for now and let's see in a new video. Okay. Bye. Thanks for now. Bye for now.